This is Colossus on the morning of the 10th of August 2005, and we now have quite a lot more of Colossus working. Particularly the counters are now all functioning, all 5 counters here, and we've now inserted the new stepping and carry system on the K wheels, and also commissioned the remembering circuits, and that's what I'd like to show now. We have on the paper tape reader, the bedstead, a re-encipherment of a known German text, a decrypt, re-enciphered on the Bream settings, and this is the tape which we use to test Colossus and also to demonstrate the settings. Before we can start doing any measurements on the tape, we have to switch various signals into various parts of Colossus. And one of the switch settings here is the selection of the output from the paper tape and sending it to what's known as the Q bus. We can select either direct Z, or in this case we want delta Z, because we're going to try and use the delta wheel setting algorithms to set this particular tape. So we want the delta Z signal, and now we can also set the delta of the patterns, and we have to select the Bream patterns. So we've selected the Bream patterns to go into the K wheels. We've selected the delta X out from the K wheels and added that to delta Z, and that is all now going to go up onto the Q bus. So it travels through to the top of the K2 switch panel to the Q bus up there. And that is where the signals which we've just selected are now available for processing with various algorithms to try and set the wheels on this particular cipher text. So those signals come down on the left-hand side there on 5 channels, 1, 2, 3, 4, 5, from left to right, and we can select various bits and to try to set the wheel positions. Now the first algorithm we're going to try here is 1 plus 2 equals dot, and that is set on the red switches down here. And so down here we have set 1 plus 2 on the first 2 switches. We're then testing it for equal to dot, and we're putting it into counter number 1. So that's the first algorithm which is normally used to try and set wheels 1 and 2 on this particular tape. The next thing that has to be done is to set the wheel start positions which we want to try against this tape, and that is done with the jack strips here, and these are the setting positions for the K wheels and then the M wheels and the S wheels below, but there's the K wheels here, and so we can set the start position for a particular wheel. We can also, on the master control switches, set whether we want a wheel to step every time the tape goes round, or whether we want it to carry from one wheel to the next to enable us to look at all possible wheel start positions for 2 wheels. So we set this, and at the moment, just for this demonstration, I have set the K1 wheel to 1 and the K2 wheel to 9. Because I happen to know those are the correct positions for matching this particular tape. So now we have the counter outputs which from running this particular set on the tape, and we had switched 1 plus 2 equals dot into counter number 1, and so here is the result of that algorithm, recording every time all the way down the tape. So this is being refreshed in the blank interval when the join of the tape goes through, and then it's counting all that algorithm all the way down the tape. and you can see there it's giving a count of 3012, 13 differing about by 1 or 2, but that's basically 3012 there is the count on that. Now, if we switch the input off of that particular algorithm, then we have the count showing the length of tape, and the length of tape there is 5,675 there. So the random score should be half of that, 2,837. But when we're in the correct position of the algorithm, we're actually getting a score of 3,012. And that is way above average. It's actually 4.7 sigma above average. So that means that in that particular position we have found the correct matching point for the Chi wheel position against the Lorentz machine settings when that particular tape was generated. But that, of course, is only that's the position where we already know the correct position. But in fact, we would normally want to explore all possible wheel start positions. And so if we set both wheels to 1 there, using the SU switch, that's now put both wheels into the 1 position there. And we can now step through one position at a time on K2. So if we put the K2 switch down, and then we do the stepping, we can now step that one position at a time there, and you can see the counts changing here because that is trying different wheel start positions all the way down the tape, and so that's now stepping through. And if we go back and do that again, so you can see slightly more clearly, if you watch at position 9, you will see that the 3012 position comes up there, 9, coming up now, and there it is, 3012. So we've stepped through the correct position there. Now, that's exploring all possible wheel start positions, but we really want to record the output on the typewriter. We don't want to have to watch the lamps all the time, and we only want to really print out on the typewriter the results which are significant, and that is done with the set totals switches. So here are the set total switches, and the switches on the far left hand side here are the switches for counter number 1, and we're running on counter number 1 at the moment. So what we can do is we can turn this to 2,900 there, 2,900, and that will now only print out any counts which are greater than 2,900. So now we can set the K2 wheel looking for the correct position, having a set total. And so here it is now, stepping round there, 3, 4, 5, 6, 7, 8. So there it goes now, 9. And there, that has printed 09A, which is the first counter, 3011. So that's found the correct position on the wheel searching through. But searching the whole of the possible combinations of wheel start position was a very long process. And the engineers, Tommy Flowers and Dollis Hill, added a very nice feature onto the Mark II, which involved remembering the previous 4 characters from the Chi stream, and then doing multi-testing simultaneously on the Z signals coming from the tape. And this speeded up the whole operation by a factor of 5, which was very impressive indeed. So on the K2 switch panel, in the center there is the R bus. That's the remembered bus, and that contains the current and the -1, -2, -3, -4 of the signals from the chi stream. And so when you get down to putting the algorithm on for the 1 plus 2, whereas in the normal algorithm you would switch K1 and K2 into the added together, you can now use the remembered bits from the remembering circuits here, like that. And so now the algorithm is that you're going to test on the first case here the current bit from the chi stream, and that's going into counter 1, and then back 1, that's -1, and that's going into counter 2. That's current -1, -2, -3, and -4. And those are then go into the counters. And then in order to engage the multi-test facility, you have to do some special switching on the master switch panel. So now you want to use the multi-test facility on K2, and that involves putting this switch down here into the K2 position, and that engages multi-test on K2. So the current bit for K2 of the current setting will be in remembering 0, and then the previous ones will be cascaded down through the remembering circuits, and so you will always have a total of 5 bits available. And those 5 bits can be tested simultaneously on the current character you're reading from the tape. And in order to do this, you also have to step. And so you have to use a stepping system on the K2 wheel, which steps every 5 positions. And so the K wheel steps 5. The K1 reader will carry and step every time. So you'll go through every possible combination of K1 and K2, but stepping 5 times faster on the K2 wheel. So in order to engage the multi-testing, we have to set to multi-test there. We're stepping on K2, and now we can now engage the stepping, and you can see that now stepping round in 5 sequence round there, and that is now looking at 5 bits at a time all the way around there, and that is going now 5 times faster through the complete number of settings of the K2 wheel. And now, by switching in the printer, we can go through the run, starting at position 1 there. There, and that now has found two counts in excess of 3,000. One at 01, 3005, and the larger one at 11 at counter C, 3011. But of course that means that the A counter is on 11, so the B counter, 1 back, is on 10, and the C counter is on 9. So that's actually 9 there. It's found position 9 of 3011, which is what it found on a single stepping run. In order to decipher the characters on the tape, the first thing we have to do is to bring into play the span counters. Now the span counters are set by these knobs here, and this is the start of the position from which you want to span the tape, and these ones here are the end position where you want to end the span. Now, we want to span just one character, and we first want to span the character right at the start of the tape. And so we have to set the first one, but not to 0, but to position 3, because of the this is to allow for the blank between the end of the start of data whole and the actual start of physical data on the tape, which is always 3 characters there, which are 2 characters blank, and then the first correct character. So the first correct character starts on position 3 there, and we want it to end at position 4. So we're now spanning just one character of the Z stream. It really is quite a remarkable achievement that of the 5,637 characters on this tape here, you can actually select one character with the aid of the span counter system, and you can actually look at the bit pattern of that one character, and that really is quite a remarkable achievement for the 1940s. The span counter panel are the master switches for switching data onto the Q bus, which is where the data is then selected to go into various counters. And here we can select either Z there, or X there, or we can select psi there, or we can put add all 3 together there. And that's what we want to do in order to be able to decipher the actual character on the tape, because we want to take the Z character, add the generated chi pattern, and add the generated psi pattern, and if those are in exactly the same position as were generated by the original Lorentz machine which enciphered this tape, then they will cancel out, and the result on the Q bus will be the plain language character, the deciphered character. So now we have various bit patterns coming down on the Q bus here, and we want to put various parts of those patterns into the 5 counters, and that's done on these red switches down here. So we pick up bit 1. Remember, this is 1, 2, 3, 4, 5 bits of the character coming down here. Pick up bit 1. We want it to be to test for it to equal to cross, and we put it into counter number 1 there. We then select bit 2 and put that into counter number 2. Select bit 3 and put that into counter number 3, and so on all the way down here until 5 goes into counter number 5 over there. So they are now, those bits are now switched into those counters, and they will now show on the display. So now we have Colossus spanning the very first character on the tape, and we have the results of the bit pattern of that character coming out here on the counters. Counter number 1 shows the bit 0 or 1 for the first bit, second bit 0 or 1, third bit, fourth bit, and fifth bit. So here we have showing the pattern of the first character, that's the Z stream, the Z character on the tape, and that is reading 11010, and that is the pattern for the letter J. At this first point in the tape, on the first character on the tape, the chi stream is generating this character, 10101. And at this first position, the psi stream is generating the first character of the psi stream, which is 01001. And now, when we add the Z plus the chi plus the S, we get this display here, which is 00110, and that is N, which is the first character of the original plain text. So we obtain the plain text character by taking the Z character, adding to it the first generated chi character and the first generated psi character, and so they had to strip those off by being added back again, and that has left us with this 00110, which is the plain language character N. Moving to the next character on the Z stream, we have to increase this position by one position there, and then increase this one by one here as well. So that means we've now moved on to start at that character 4 and finish at character 5. So we're spanning character 4 on the tape there, which is the second character of the actual data on the tape. We've stepped the spanning on one character, and so now we're looking at the second character from the tape, and we have the bit pattern for that character 10100, and that is S, and that is the second character, the second Z character, the second cipher character on the tape. And at this second character point, the chi stream is generating a pattern of 10111. And at this second position, the psi stream is generating 10101. And so now, if we add the chi and the psi to the Z, then what is revealed is 10110, which is the letter F, which is the second plain language text of the actual original German text. So that's the second letter F, 10110. Character in the Z stream, this coming off of the tape, we have 11110, and that is the letter K. So that's the third letter on the cipher text. And at this third character point, the chi stream is generating 11000, and the psi stream is generating 01100. So now, when we add back the chi pattern and the psi pattern to the Z pattern, then we get this pattern here, 01010, and that is R, which is the third plain language character which we've now deciphered. Now we've stepped on to the fourth character in the Z stream, coming off of the paper tape reader, and that is 00110, which is N. That's the fourth character of the cipher text. So now we have the fourth character off of the chi stream, which is 10000. And the fourth character of the psi stream, 01001. And so now, when the chi and the psi characters are added to the Z character, we get 11111, which is a dash, which is the fourth character of the plain language input stream, which we've deciphered there. Now we have the fifth character of the cipher stream, the Z stream, 11001, which is letter W. So that's the fifth character of the cipher stream. At that fifth point, the chi is generating 01111. But the psi stream is generating 01000, 0, 1, which is the same as the position at the fourth position. So the psi wheels have not stepped on. So under the control of the motor wheels, this is one of the positions where the psi stream stays stationary from character 4 to character 5 on the input Z stream. The fifth Z character, and taking the fifth Z character and adding to it the fifth chi and psi, we get 1, 1, 1, 1, 1, which is a dash, the second dash. That's the character number 5 in the plain language stream. And now we're on the sixth character of the Z stream, 1, 1, 1, 0, 1, which is the letter Q. At this point, the chi stream generates 0, 0, 1, 1, 0. And this time the psi wheels have stepped on 1 under the influence of the motor wheels, and the new psi pattern is 1, 1, 1, 1, 1. And now, with adding the chi and the psi to the Z, we get the plain language character 0, 0, 1, 0, 0, which is the dot character. And so this time the psi wheels have stepped on correctly, and the result is the correct decipherment of the plain language. Now we're on the seventh character of the Z stream, and this is 0, 0, 0, 0, 1, which is the letter T. At this point, the chi stream gives 0, 1, 0, 1, 0. And again, the psi stream has not incremented. It still gives 1, 1, 1, 1, 1. Now, adding the chi and the s to the z, we get 1, 0, 1, 0, 0, which is the letter S, which is the next character deciphered from the ciphertext, and that's the plain language character S. So here is a representation of the streams. First of all, at the top here we have the Z stream, and so here are the characters coming off of the cipher text, off of the paper tape: J, S, K, N, W, Q, T, R, etc. there. This is the deciphered letters which we finally get when we add the chi character and the S character back onto the Z character. And so here's the actual plain language decipherment there, NFR dash dash dot SCHERN for. And here are the patterns for the chi wheels and the S wheels. But the important thing about the psi wheel patterns is that they stutter. So here you can see that it changes on from the first to the second character, second to the third character, third to the fourth character, but then stays the same on the fifth character, changes to the sixth, stays the same on the seventh, and then changes to the eighth, and stays the same for the 8th, 9th, 10th characters there. So that shows the stuttering of the psi stream.